Can you see my screen?
Yeah.
Okay, good morning, everyone. So welcome to the third session of our program. And today we have quite a lot of content to cover. The objective of today's session is to kind of get familiar with the tools, the frameworks, and use cases of generative AI. And we look at what are the most industry leading tools and frameworks that organizations are using to develop different applications and what kind of use cases they're looking at. And we will have some hands-on also today. I had a hands-on session last Wednesday, but I think I will do some more hands-on exercises, and a couple of them important ones I'm going to repeat again today for the benefit of all participants. And I have sent an email for you to sign up for OpenAI and install Olama. Even if you're not done that, you can of course follow the instructions and do it later. Again, I will have another session in the middle of the week in case you have any questions, any difficulties. You can always, I'll help you out. But today, of course, there's a lot of content there, so I'm going to go through all the content step by step, and you can follow and reproduce some of those things on your own in the coming week. So let's get started. We'll do a quick recap of the things that we learned last week in last session, and we will move from there. So I think the one of the most important thing that we learned in the last week is kind of how do we actually leverage this prompt concept, right, to develop quite a few solutions. So we understood what a prompt structure is. So prompt is not simply asking a question, because these models are fine-tuned on a lot of this structured prompt to accomplish different kinds of tasks, right? So they're very well versed, these models are well tuned to the structure of the prompts. Of course, the structure of the prompts would vary from provider to provider, though they won't vary in a significant way, but some of the nuances would differ from OpenAI to Anthropic to Llama model and all that. But overall, there is a prompt structure. Like there's a role, there's instruction, there's examples, there's a question, there's a context and all that. So you understood that. Then we looked at some of the emerging, prompt techniques. Like we looked at what is zero shot and few shot prompting, where we actually give examples to the prompt in the prompt for the model to learn in context. In the prompt itself, we provide those examples, and there are certain best practices how these examples has to be given. And then there is something called chain of thought, where whatever you ask, it gets decomposed into smaller subtasks. Chain of verification, where it verifies some of the generated output, which can be done in a single or multiple different steps. And then we have something called self-consistency pattern, right? All those patterns, we just ensembling techniques. We looked at. Then we also looked at some of the best practices. For example, how to provide clear instructions, how to use delimiter, right? How to provide schema for a structured output, right? So this every model provider like OpenAI has a set of best practices. Anthropic Claude has a set of best practices. They would have common best practices, but some of the subtle differences would also be you should be quite aware, especially if you're working on a specific model, provider. Then there are certain patterns which emerge to accomplish certain tasks. For example, structured information extraction, where we have to provide, the schema or the pedantic class. Summarization patterns, we look at how to summarize something, either based on a map reduce or a refinement pattern. We looked at those things. Then conversations, singleton conversation and multi-turn conversation, where we have to have the memory of the past conversations, which sets the context for the future conversations, right? So we looked at those things as well. And we also looked at some of the control parameters for generation. Control parameters for the generation, like we had temperature, top P sampling, and penalties, right, for creating new content. So those also typically most of the models would provide these three parameters, and you can control. So like a temperature very close to zero will be more deterministic. The content, every time you ask the question, the content or the response would remain very same. But if you increase the temperature, it will be more creative content. Every time you ask, there'll be more different kinds of the response generations would be there. So these are the important things that you must be aware when you're working with generative AI. And how this is going to help, of course, we'll look at some of the use cases today. Besides that also, so because today we look at a lot of these tools that enhance your ability to interact with the generative AI models. And so we look at some of the important tools that has evolved over a period of time. And some of those tools are given by specific providers. For example, there is something called prompt generator. So there is a tool which can actually write the prompt itself, because the prompt has to be so descriptive, very clear, and it can decompose your task into subtasks. Sometimes it could be very verbose, right? So you writing that prompt from scratch could be time taking, or probably take a lot of time. So there are tools which can actually write the prompt for you itself. Of course, it can write a base version of the prompt, and then we can make some modifications, add some important points to that, and then give that, and that would actually ultimately generate a much better response. Right? For example, here Anthropic actually provides something called prompt generator. Just give me a second. So if you go to Anthropic console, so there is something called, you can write the prompt on your own from the scratch, or you can generate a prompt itself, or you can also improve an existing prompt. You can actually give an already existing prompt, and you can ask what all aspects of the prompt can be improved so that it will generate a better response. Of course, these are little bit of tuned towards Anthropic's prompt best practices, but you can actually generate and use it other models as well. Okay, with a little bit of modifications. A simple example is, let's say, I want to write a product requirement document, PRD we call it, for the system that we discussed in the first session, right? Aspect-based sentiment analysis. And I want the model to the chat GPT or Anthropic, whoever, to kind of write a very comprehensive product requirement document, right? But then the prompt could have to be very elaborate so that my response would address all these aspects of product requirement document. So what I can do is I can just simply write a small um, concise description of what I'm trying to do. So to write a product requirement document for developing a system to review and respond to the customer reviews of a restaurant, it should take care of the detailed analysis of the reviews, personalized response, and take care of all system requirements. So what I can do is I can give this to the Anthropic, generate a prompt, and then ask it to generate. It'll take some time, but if you see, this is what is the prompt has been generated. And it actually follows all the specific techniques that we discussed in the last session. Like you are tasked to write a PRD document for developing a system, and it gives some examples of what's a restaurant name and what existing review. So it will actually have some not pre-filled, some placeholder that you can replace later. And the PRD document should have the following sections. You can see, because these models are designed on with a large corpus of data, they've already seen a lot of these PRD documents. So it's saying that it automatically lists the PRD document should contain what are different sections: introduction, review analysis, response generation, system requirements, user interface, database integration, scalability, reporting analytics, implementation timeline, success metrics. Right? You can see it lists out all line items that should be available in the PRD document. Then what you can do is you can take this. You can see that here also it actually generated a particular prompt. Now what you can do is you can take this particular prompt, and you can see it has again actually also given some placeholder to replace them. And it also has created sections, and it also has created a template for creating sections. Very interesting. System overview, user requirements, functional requirements, and so on and so forth. Now what I can do is I can take this particular prompt and ask Claude or OpenAI, right? Now I can go and give this particular prompt. For example, here I've given this particular prompt and ask it to generate the actual product requirement document. So you can give a concise description of the prompt and take help of the prompt generator to generate the prompt itself. And then, of course, you can make some modifications to that and then bring that and use that as a prompt to generate the final response. So in a way, it actually enhances the productivity because writing this prompt itself take a while, and we probably not address all different aspects of the PRD document. And there is another feature which also is provided by, this is provided by the OpenAI and is also available on the Claude itself. In fact, quite a few models are now providing this concept of Canvas. Canvas is a very important feature and very useful, and a lot of people are using it now, but though it's available on only paid version of OpenAI. So what you can do is you can, when writing a prompt, you can actually select the tools called Canvas, right? And then you can actually write this prompt. And then what it does is it opens up a canvas on the right. So you can see this is a canvas where it is given the response. So this is a initial version of the product requirement document addressing all these aspects that the prompt has specified, like a review analysis, system requirements, and implementation timeline, everything. And of course, this is something that not directly usable. You can probably have to make modifications, but at least you got the initial version of the product requirement document. Now, the useful thing about Canvas is you can review it and edit it online. For example, let's say I want to this particular aspect here, right? I want to make little more detailed. So what you can do is you can select this one and ask ChatGPT here itself, can you elaborate on this point, on this aspect using some examples. And what you can do is now you see that it only make modifications to that particular aspect of this particular. It expands on that particular point here itself. So you can actually edit it online, live, and this is more like a collaboration tool. So initially we had simply a question answer kind of an interface, right? You simply ask a question, response, then you ask a question again. But now this has gone into something like collaboration. Right? So you have a response generated, and you can review and make specific modifications, which ultimately goes as a request to the model, and make modifications depends on what is the ask here, right? And and that way you can slowly evolve, especially important, especially when you are doing it large documents and responses if you're creating. So these are very important tools, these tools that you must be aware of and probably leverage to enhance productivity. A lot of this project managers, product managers actually use these tools. So one is prompt generator, which can actually generate a more well articulated, structured prompt from a very small description of what exactly you want. And you can leverage that prompt to generate the final response. And once you've generated the response itself, you can collaborate on the response to edit and evolve it over a period of time using something called prompt canvas. So these are the two important tools that you should definitely leverage and use it. I will wait here for 30 seconds if any questions. But of course, this particular feature should be available on the paid version, but it's worth it. Let me know if you have any specific question. Okay. If you look at the type of models that you can use, there are different kinds of models are there. Depends on the modality. For example, nowadays, most of these models are called multimodal LLMs. So they can actually take multiple different inputs, types of inputs, like a text, image, audio, and all that. For example, if you look at OpenAI itself, there are at least five different kinds of models. The typical chart GPT, what we see, GPT-4o is primarily text and also multimodal. You can, text and image or text, you can actually add to that. There are also image specific models are there. Primarily text to image, you give a description, it just generates an image. This is primarily for creative content generation. People who work in the field of creative content, they actually use a lot. like a DALE model. You must have heard about DALE model. Then there's an audio specific model also there, which is the two types. One is called STT and TTS. This is called speech to text model. Speech to text model. So from audio to text, this is actually used also for a lot of transcripts. And there's also something called TTS, which is text to speech. You can generate a speech, and the style can also be controlled. The voice modularity can be controlled depending on the model, of course. So Whisper is basically a speech to text model, and TTS1 is your text to speech model. So there are specific models for different modality, for example, different types of input, but there's a generic which is multimodal, which is basically your ChatGPT. Then there is an embedding model, which we have seen already, is especially for converting text to embeddings. This is for creating search kind of, or today we look at something called RAG system, we use a lot. So the numerical representation, we have gone through this embedding concept in the first session, which is an important concept. So convert text to embedding or image to embeddings also for image search. This will be very helpful for image search. For example, you must have heard about nowadays people are building solutions when you can upload an image, especially for, let's say, fashion retail, right? When people upload, it tells you similar products that might be there in the catalog, right? So text to embeddings and image to embedding models. And then there's something called also moderation API. Moderation API is something that we'll address in the next session, is especially for safety detection. So most of the models, so just to give a quick overview of how ChatGPT works. So in ChatGPT, when you ask a question, right, in ChatGPT, when you ask a question or when you write a prompt, let's say prompt, it actually goes through three different models, not one single model, right? It actually goes through three different models. So the first one is basically a moderation API, which is basically a filtering, input filtering models, right? It first tries to understand whether the prompt has a good intention or not, like a toxicity detection, right? Harmful content. Let's say you're asking a question and with the intention of causing an harm, right? Or it has things like bias, all this information detection. And once it detects, then it basically decides whether it should actually generate a response or should not generate a response. For example, sometimes if you see, let's say how to make a bomb, right? It basically say, no, I'm not actually allowed to, or it's unsafe, I cannot respond to that particular question. So first it goes to a filtering model to understand whether the prompt should even be responded to or not. And then if it clears that, then it actually goes to your GPT-4 model, right, which actually generates the response. And once the response is generated, it also again goes through a filtering mechanism to check whether the response itself has some content that is not aligned to typical our ethics. So whether it actually violates any of this ethical standards or not, right? Only when it clears that, then only actually the response goes to the your UI, which is ChatGPT UI. So all prompts basically typically goes through three different models. The actual model is in between. So there is a pre-filtering for filtering the prompts. There's also a filtering mechanism for the response itself. In fact, this is a very good, you know, pattern, architecture pattern, typically used by even applications. When you create applications, when you integrate with your models, you should also have to have this kind of verifications. And your moderation API provides that. We look at that. It actually looks at various aspects, whether the prompt has toxicity, is it bias, is it fair or not, is it a hateful comment, is it a harmful content? All this basically detects. So that's an actually a very important set of APIs. And if you look at other providers also, they will have a very similar kind of models. Okay, there's a question by saying that are there an image to image? Um, yeah, image to image, you can use same chat GPT itself, GPT-4, which can take and text an image. You can provide an image and give us some description. You can generate an image. They're not pretty good though, but yeah, to some extent there is. DALL-E also can do to some certain extent, can also do. Then there are different API types are there, right? There's some API types are there. One is called chart completion. Whatever the API that you see, typically is called chart completion API. Then there's something called real-time API. Real-time API is speech to speech. Nowadays, of course, in ChatGPT itself also you can do. You can provide a speech. You can actually talk to the ChatGPT, responds with the audio as well. Then there is something called batch API. This is primarily generated text from a prompt. This is speech to speech. Batch API. In batch API, this is quite useful for building production applications. For example, in the restaurant review, just to look at the example, in the restaurant review, what I can do is you don't need to review, classify the reviews as soon as the reviews are written. What I can do is, of course, depends on the use case. Every day, night, right? In a batch, you can run all these reviews. Let's say today there are about 10,000 reviews are there, and those can be run simultaneously. So there's a batch API, which is typically low cost, much lower cost, rather than real-time chart completion APIs. We can send all these 10,000 reviews and ask them to classify in a batch. It's asynchronous. You can just submit it and automatically generate a response and let you know. You want to save the data somewhere and then find that out. Then there is something called assistant API. This is primarily used for building your conversational AI agents, right? Which kind of take help of tools and integration with the other components. We'll look at some of these things a little later, right? Of course, the most important API people use charts completion API, which is widely used. But real-time API is also quite evolving now because a lot of people are looking at audio as an input rather than text as an input. Okay, so what all different use cases that we can actually develop? So there's a nice case study here from a DoorDash. DoorDash is very similar to our Zomato that we have in India. This is a very nice case study, which also gives us some kind of insight into how organizations are looking at generative AI to develop systems for their organizations. So they've identified that generative AI helps in 5 different tasks, 5 different use cases. And these are the 5 ones that I've highlighted here as well. Of course, you can go in detail, read that case study, not big one, but of course, we'll go through, explore all of them in detail today. One is the assistant to customers to complete different tasks. So this is primarily, you can think like your chatbots, right? So before generative AI came into picture, developing chatbots were extremely complex. So there were models like intent classification, right? And which is not very accurate models, but and not very conversational in nature. So today you can actually use generative AI to develop these chatbots in much better, right? And this is one of the use cases that can actually you can develop. Then there's something called information discovery. This is where your RAG systems come into picture. Um, so because generative AI models are primarily built or trained on public data, they have a little information about the private data about organizations, right? And organizations typically have quite a lot of data. They have like documents or infrastructured or unstructured data. So now can we integrate that, right, with the generative AI model, right, to kind of, do information discovery. This is also called information retrieval systems. So we'll explore RAG today, how RAGs are built. Generation of personalized content. This is, of course, very specific to DoorDash, but this is also an important aspect. For example, when nowadays product descriptions on the catalog. So when you go to log into a particular e-commerce portal, so the product descriptions are typically static. That means every user would see the same description. But what people are doing today is they look at the user's profile and then past purchase and past interaction information, and then explore or extract what different or important aspects that typical the user likes or prefers, the preference of the user, and based on that the description of the product would change. For example, a product has, let's say you're buying a mobile device, right? So some people, let's say some user typically gives importance to the battery life, and somebody looks at the camera, and somebody looks at other different aspects. Let's say we have that information. Then when we look at the product catalog information on the portal, because we know the user's preference, we can rewrite that particular product description in a very personalized way, which highlights those aspects of the product description, right? So that's a very important use case people are using nowadays. In fact, a lot of this organizations, especially e-commerce platforms, are leveraging um, generative AI to create personalized description of the products. But that's one wonderful case study or use case that generative AI can be used. Then extract structured information. This is, of course, an important case. And if you look at from the DoorDash perspective, um, cataloging the products. So when a vendor comes in and adds some SKU to their catalog, so the product description, the product has to be added to the right category or a subcategory and has to have a right tags so that customers can actually search for the product, right? So uh, today, if you look at, there will be a lot of humans are involved to kind of create those tags for the products. Or there are probably certain models like NER models, traditional NER models to extract those information from the products. But today, generative AI can be used to extract those information. So structured information extraction that we discussed last time also is one of the important cases. Then enhance employee productivity. For example, just now we saw how we can use prompt generator or prompt canvas to quickly write a product requirement document, right? So this can also be involved, also be like code development, system software development, right? Software development. So nowadays everybody uses, or most people use tools like GitHub Copilot or Cursor, which enhances the productivity of the employees. So these are actually, in fact, this is a very good article which talks about some of the important use cases that organizations are leveraging generative AI to develop. So chatbots, RAG systems, so information discovery, personalized content generation, extraction, structured information extraction, and productivity. So we'll actually kind of explore some of these ideas today and look at what tools and frameworks are available to accomplish these tasks. There's a very recent study done. In fact, this study was done last week only. If you look at 12th December, this is just 2 days back. This particular report was published by Anthropic. Very interesting report. It's called Clio, Claude Insight and Observations. So they looked at the kind of prompts people are writing and try to understand what kind of tasks people are doing. The millions and millions of prompts, right, every day. So they have a lot of this wonderful information without exposing, of course, the privacy information from the prompt. So that they would eliminate those personal or privacy information from the prompt and primarily look at the high level tasks that they are doing. And they've also provided how they are doing it, how basically they have done this analysis without exposing the privacy information. For example, if a prompt is like this, how do I tie my shoes? I'm 27-year-old, it's a bit and all those things. And they simply, extract the topic from it. The topic is how to tie shoes, right? Similarly, can you tell me about a particular deficiency syndrome? Okay, so they basically summarize this. So why aren't CSS animations working right? So this is about web development. So from the conversations, the actual prompts, they are extracting the facets by summarizing or extracting important metadata from it, and then they're creating clusters, topic clustering, and then they're creating hierarchies, right? And then they found that these are the most important tasks people are actually doing. For example, almost 10% of the requests, and this could be very specific to Claude also, because Claude models are typically excellent models for code development. They're typically people prefer Claude models over ChatGPT for software development. So almost 1/10 of the people use for questions prompts like for web and mobile development, then content creation and communication, academic research and writing also people use. Actually, in fact, we use a lot. Then education for learning and all that. Business strategy operations, right? Digital marketing, SEO, data analysis, visualization, model building. So you can see the kind of tasks people actually accomplish, top use cases on cloud AI. People are using it. So that's why if you look at the overall, the way people leveraging generative AI, so these 6 use cases emerge. So we have done quite a few case study analysis and found that these are the top 6 use cases people actually use generative AI models for. One is increased productivity. This is for both software development and even for product management or project management, right? Any kind of productivity that we do manually, we can now leverage generative AI. So your prompt generator, Canvas would be an important tools to, doing that, even GitHub Copilot and all that. Then structured information extraction, AI assistant. This is very similar to the one in the case study. RAG, this is an important use case. RAG. Then content generation. This is primarily for creative content, right? Creative content or personalized content. And then there's something called automation, workflow automation through agentic workflows. So in fact, the way trends are emerging, this is going to be the most important use case in 2025. Agents, we'll look at agents in a little more detail. Agentic workflow automation. So a lot of these workflows can be automated using agentic frameworks. So now let's look at this use cases and what tools you're available for doing this. So now I'm going to introduce a set of tools or frameworks. Let's call them frameworks. They're not actually, some are tools and some are frameworks. So a mix of both. And these are the industry leading frameworks that you must be aware. And whenever you're building solutions, you should always evaluate them, because they are going to be, improve your productivity, or, they're basically the abstractions on top of typical your LLM models, and can actually develop this products much faster. So one of the most important tool or framework, one of the most important framework that you will encounter is a LangChain. So they are one of the initial frameworks to be developed, and still today they are one of the most widely used. And LangChain framework, of course, it actually has a lot of different integrations. I'll just show you LangChain framework. So this is the most important framework that we'll encounter for building applications. And if you look at the LangChain documentation, right? So when you build generative AI solutions or applications, you might have to deal with so many different models and different components. All right. So LangChain already comes with the integration of those different models and tools. So if you look at the components that's already comes integrated with a lot of these models, chart models, retrievers, tools, vector stores, and embedding models. Just quickly show you. Let's look at the models, chart models. So as you can see, this is already integrated with a lot of these models already. Anthropic, OpenAI, Vortex for Google. Right? Because if you want to integrate independently all these models, there's a lot of work actually. But you can provide a common abstraction on top of these models, then probably it will be much easier. Then Cohere is basically a model. And there are some of the proprietary models are there. For example, Anthropic is a proprietary model. OpenAI, of course, a proprietary model. Cohere is a proprietary model, but there's also some open source model also there. For example, Llama, must have heard about Llama. And so here's a set of different models. And today there's quite a few actual models are there. But most of the times, of course, you'll be using the top models. And remember, in the first session, I have shown you there are two different leaderboards. One is your LMSys arena, where you can see what the top performing models. And then there's a Hugging Face leaderboard also, the top performing open source models. Then there are also like embedding models, right? There are quite a few different kinds of embedding models. So OpenAI has embedding model, then Together is embedding model. Hugging Face also has embedding models. All these embedding models integrations also given by, by LangChain. Vector stores, something that we will also look at while discussing RAG. So they are vector databases to store the embeddings and do search based on the embeddings. Then tools, right? So in case you want to, like last time we discussed about enhancing the capability of interacting with LLMs with something called function calling or tool integrations. So this also comes with the ready-made integration with a lot of these tools like a search tools, Bing search, DuckDuckGo, very popular search tool. Then code interpreter tools to run code as well, right? And then other productivity tools like GitHub, Jira, Slack, you can directly integrate. So you can ask a question, it can integrate with Slack and retrieve information from the Slack as a context and respond to it. Web browsing, also databases. You can see a lot of these tools are it comes integrated. So LangChain is actually a wonderful tool if you are trying to build a solution that you have to talk to LLM, you have to talk to embedding models, you have to talk to vector stores, you have to talk to different tools, then this provides a nice abstraction, on top of that. So LangChain is going to be one of the most important tools that you will leverage. So we'll look at some of the features it provides that you'll be dealing with, and I'll show you a couple of examples as also. One is dealing with something called prompt templates. So when you're writing applications, you'll encounter a concept called prompt template, right? Prompt templates are like we normally ask questions prompts, right? For example, if you're doing an aspect-based sentiment analysis and you will have something called the role and the system instruction, and there'll be something called user message. Remember, in the prompt, there'll be something called system message, and there's something called user message. So let's say you want to classify different reviews. So your system or instruction message will not change. This will remain mostly constant. All that will change basically is your what? Your review, the user comment. So you can write a prompt template with the system message is fixed and there'll be a placeholder for the review. So every time what you do is when you use these frameworks, you'll use the template to replace this placeholders with the reviews. And then this will actually generate the actual prompt, right? Using the system instruction and the placeholder replaced by the actual content, and will generate the actual prompt and send to the LLMs, right? So in organizations, what you do is you will actually create a lot of these prompt templates. And these prompt templates can be actually managed in the repository. People actually can reuse them. For example, there is another prompt template here. Given a text, can you generate an SQL statement? Right? So you can actually see there is a system instruction here, and there are specific placeholders to fill in based on what kind of questions. Based on the questions also, you can actually specify which table to look into, right? Even some examples also. In few short examples, this can be later filled. So this is called the template, and the template can be completed by replacing the placeholders with appropriate information, and then the actual prompt would be generated and that can be sent. And LangChain actually makes it much easier to generate those prompt templates. We'll look at one example now. So there is also something called prompt hub actually. This is a very interesting concept given by LangChain. So a lot of these prompt templates are pre-built for different kinds of tasks. Of course, you won't use them directly. You can also use them directly, by the way. But you can actually, rather than writing these prompts from the beginning, from the scratch, you can actually leverage them and improvise on top of that. So LangChain actually has something called prompt hub. There's a lot of this terminology you have to very carefully and So this is actually LangChain hub where you have all these prompt templates for different kinds of use cases already there, right? For example, let's say um, classification, right? And you can see there are a lot of these prompt templates are there. People have already written, and you can also see how many people are currently using them. Also, you can also see by top viewed or top downloaded prompts. Let's say look at one prompt. Click on the prompt, and this is the prompt. You see that? Um, this is for writing code, I think. No, this is for creating prompt itself. So you can see there's a huge prompt that's already written. You can directly leverage this. Let me see if there's some simple ones out there. Just explain. Yeah, this is the one that we are actually looking at. Aspect-based sentiment analysis. This is the one, the prompt template. This is the in system instruction. This is the placeholder for the reviews. And this is how you can directly use it actually in your application. You can simply pull it from the hub and directly use it. Of course, if it's not directly useful, you can also take it and edit it. You can also edit in the playground. You can make some modifications, add some comments, some more instructions to that, and then create your own uh, instance of this particular prompt, another version of it, and then directly use it in the applications. The whole idea is when you're developing applications and you are doing any of these tasks that's given here, like use cases, whether it's about creating a chatbot, classification, code writing, extraction, SQL summarization, and all that, what you can do is you can um, see if some of these existing prompts can actually help you or at least get you started with writing those prompts, right? Not necessarily they will be useful as it is, but you can always you know use that as a base prompt and improvise on top of that and leverage that in your systems. So that's a very interesting feature of LangChain called Prompt Hub, and very, very useful, to increase your productivity for writing these prompts. So besides providing integrations and framework for integrating tools, vector stores, models, and all that, it also provides a something called what? Prompt template and prompt hub. There's also a concept called prompt chaining. Sometimes to accomplish a task, sending one single prompt to the LLM may not help, right? Sometimes what we may have to do is, uh, you know, you send a prompt, let's say prompt one to the LLM, and then the LLM responds. And then what you do is you add that response to the next prompt as a context. So this response is added as a context to the prompt. So given this is a response, so you basically it's more like a least to most prompting. If you remember the technique where we accomplish a task by decomposing, but in a sequential fashion, but doing the subtask a step at a time. So you again send to the LLM. So if you see in step one, so this is a very interesting from a story, can you write a complete script? This is simply an example is given here, but this can be also used for doing any of the complex tasks, right? So for example, writing code, you can write a boilerplate code, then you can improvise based on, creating modules, then generate documentation for those modules, then writing test cases for those modules, right? So you can see in a sequence you can develop, like you do software development, also you can do it. So you write a short description of the story, and then it's going to generate a title, one prompt to generate a title. Then you take that and generate characters, then take that story and characters, then you can create a story beats, locations, and dialogues, right? You can see the previous output of the LLM goes a context to the next LLM. So again, those two added goes as the to the next LLM. So on and so forth, right? So this is basically called prompt chaining, where multiple prompts are chained in a sequential fashion, where you send one prompt to the LLM, get a response, take that response, add as a context to the next prompt, get another response, then add the previous response as a context to the next prompt, and so on and so forth, until you accomplish all the task. This is, of course, very similar to least to most prompting, technique. Okay. But prompt chaining not necessarily has to be, uh, sequential. It can also be parallel, right? Especially if you look at this is a least to most prompt technique, and this is more like ensembling, right? Or you can also look at something called summarization patterns, where you can create multiple chunks, right? And then you summarize all of them and send to the final, combine and create the final summary. So this can be sequential or can be parallel, or it can also be like you send a prompt, for example, self-consistency. Remember self-consistency? So you can send the varied prompts to different models, and ask models to generate different kind of responses, and see, which of the responses has highest voting. For example, you want to classify a particular sentence, and you look at which of the models has a uh, you know highest number of classes. For example, if you say is a positive or negative, this is of course a simpler application, but can be also used for any advanced applications. So let's say this says positive, this says positive, this says negative, right? And then you combine and say, okay, because most of the models are saying positive, it must be a positive, right? More of ensembling techniques. So what LangChain does is, LangChain actually provides this kind of frameworks to develop this kind of techniques and applications, right? One is prompt template and prompt chaining. And also it has a prompt hub, which actually can, you can leverage to, reuse some of the prompts that people have already developed and use there in the applications. Make sense? Any questions so far? So let me show you a demo of it, so that will make it much more concrete. The understanding is, so I have actually created a GitHub repo for all the examples, hands-on lab examples. Yeah. This is something that I shared in that Wednesday session, but I'm going to share it here as well. So Atul is asking a question, any competitor tool for LangChain? Of course, there are quite a few other tools out there. Llama Index itself is Llama Index. We'll again see that Llama Index. Then there's a DSPY framework. There are quite a few frameworks are actually there. But some of these frameworks probably are focused on a specific aspect of or specific types of use cases. LangChain is more like a broad, right? It has support for prompt chaining. It has support for RAG systems. It has support for agents. But then there are other frameworks which are emerging, uh, especially for agents. We look at one tool called Crew AI, which is very widely used framework. And Llama Index, though it supports other use cases, but very strong on RAG systems. So let's look at one example here. So I'm going to run through this example now. This of course requires your OpenAI key to run these examples. I have few examples to run it on the local system as well. I'll show that. I have currently 5 different examples hands-on to show. One is prompt template and chaining both. Structured information extraction, I will show you later. And I have also one for RAG system and one for agents. Right, the 5 different examples are there. If required, I'll add a few more for the next week. So I'll start with the first one. Sorry, let me start the first one. So all that you have to do is right click on this link and open in a new tab. It'll open in Google Colab. Again, the idea is not to go to very deep dive into the code. I'll just show you at overall, how these systems look like. This is primarily to introduce to the OpenAI API. And the next one is to introduce the LangChain API or framework. So you can connect. I can assume that most of you would be familiar with Google Colab. So you can provision a machine and install OpenAI. I think nowadays it comes with OpenAI installed, pre-installed. So you can see that it's already satisfied, saying. And then for the platform, platform.openai.com, if you log into that, you actually will have something called a dashboard. You can see there are options called playground. I think something that we explored last time called playground, where you can actually control the model, the parameters and all that. There's something called dashboard as well. In the dashboard, you can generate some keys, API keys. You create API keys, which can be used for the APIs. On the usage side, you can buy some credits. For example, typically I use about $10 credit limit, which is pretty good actually, because they charge about $1 for 1 million tokens, which is very high. So I never cross like $6-7 in a month. So that's not very expensive actually, if you see the kind of usage. And running these examples, probably you're not been spending more than $1 or $2. But to get familiar with this, you have to use a API key. And And those API keys has to be configured in the Google Colab. So Google Colab actually has something called secret store. This is very similar to if you're familiar with the cloud solutions like Key Vault in Azure, where you can store all the keys rather than hard coding the keys in the code, because that will expose the keys, right? So what you can do is you can key store. You can actually add those keys here. For example, I have stored the key called OpenAI API key. And if I want to use it, I simply say, can you give me the key? And configure for the OpenAI. So I'm initializing the OpenAI here with the key. And initially, for the first time when you do it, it might ask you to grant access to the store. You say yes. And now OpenAI is configured now, OpenAI API, right? So now all I have to do is basically I have to call this something called chart completion API. Remember, we discussed this now. The different type of APIs are there. Chart completion API. This is simply typically a prompt response kind of mechanism. So client, which is your OpenAI, and it's a chart completion create, and you can specify the model that you want to use. This has come from the OpenAI set of models that you can use. And this is the prompt that you're sending. And the prompt has two components. One is the system message, which is basically instruction, what you want to do. And this is the actual message. So in this case, I'm sending a review, okay, about a product, and asking the review is about which of these particular, categories. And simply you send that message. You can also set temperature, top-pitch sampling, and all that. And once this is run, it actually sends back the response, and you can look at the response content. Okay, basically say, okay, this particular review talks about 4 things. It's easy to use, but poor quality, difficult to transport, difficult to store. Okay, whatever that product is, it gets that. So this is how you interact with the OpenAI APIs. This is, of course, OpenAI APIs. I'm going to show the LangChain one, which is more abstraction on top of that. The second one, I'm going to show prompt template and prompt chaining. Both is here actually here. Again, connect. And once you connect, you install OpenAI, LangChain OpenAI. So OpenAI is OpenAI API. LangChain OpenAI is basically the LangChain's integration with OpenAI. Right? Depending on what model you want to use, you have to install that one. That's part of the documentation in the LangChain itself. We can actually check that. Right? So whenever you go to the integration page on the LangChain, and let's say you want to use Anthropic, it says pip install LangChain Anthropic. And also shows in a simple example of how to invoke that. So every model, Hugging Face model, LangChain Hugging Face, right? You can say that. And then same thing, you can get the OpenAI keys. And then I'll show you a few examples of zero-shot prompting and few-shot prompting. Okay. And then I'll also show you the chaining part, 3 different. So the whole idea here is the basic example that we discussed in the first session is send a review and find out which particular um, uh, category it belongs to, the review, the restaurant review. And then based on that, can you also trigger a mail response to that review, right? So chaining. So at the end of this exercise, you'll look at the review, classify that review, And based on the classification and the sentiment aspect-based sentiment type, it'll also generate a mail response, which is attuned to that. One is zero shot prompting. So this is chart OpenAI. This is the LangChain version of OpenAI API. Here you can specify the model, temperature, max tokens, and all that. And you can simply write a prompt. So what's the sentiment of the customer review? And basically ask for sentiment. And you can actually print, it's a positive sentiment. Right? This is of course simple one, but every time you ask for the new reviews, what I have to do is this particular review cannot be hard coded here. So this has to be some placeholder like review, right? So to accomplish that, what you can do is you can use something called a prompt template. So this is what the prompt template is. The LangChain provides. So you can write a template and saying that this is the system instruction, this is the task that you have to complete. And this is the review. And this is the sentiment that I'm expecting. And once you create the template, you can define template saying that there is a variable called review text, which can be replaced by the actual reviews later. Let's say I have 5 reviews here. 1, 2, 3, 4, 5 reviews. The reviews, different kinds of reviews, some are positive, some are negative, and so on and so forth. So now if I want to send a prompt to the OpenAI, all I have to do is, sorry, I didn't expect this. So now what I can do is I can create a prompt chain, which is which LLM and which particular template, right? So this is the template, and this is my model that I'm going to use. Okay, and then simply invoke it, saying that, okay, can you invoke this particular LLM chain for this particular review? So what I'll do is we'll take this particular review 0, which is the first review of this, and use the template to actually replace this variable and create the actual prompt and then send to the model, right? So this is very, very streamlined way of writing this. I simply say chain invoke for this. Okay. So you can see that the text is positive. Okay. Now you can iterate through all the reviews and simply invoke. Okay. So the first one is positive, second one is positive, third is negative, fourth is negative. I think, yeah, 3 are positives and 2 are negatives. Right? Got that one? The simple one. You create a template and use the template to create the actual prompt by replacing the placeholders and send it to the actual LLM. But this is without giving any examples. Sometimes you might have a very complex task where the model is probably not trained on that kind of data. So what you can do is you can actually create some examples. So rather than positive and negative, I may also want to classify with which particular category it belongs to. The review belongs to food quality, hygiene, ambience, customer service, and all that. So you can actually create something called few shot prompt template. So these are the examples that can be embedded into the system message also. So whenever I send, these examples can also be sent. It also has a mechanism to kind of, let's say we have hundreds of examples to find out which example is appropriate to be embedded into the context. Also, they have a mechanism for that based on nearest neighbor kind of techniques. But I'll just show you a few examples here. So This is the review and template. Yeah, this is the few sort template. So you say classify the review into one of the four categories as given in the examples, right? And here you are actually providing those examples that we have here, examples. This is hard coded here, but not hard coded actually, but we are providing all the examples, but you can also provide specific examples. And then we have a reviews. Sorry. Okay. So actually, if you see, it actually creates a uh, prompt for the first review saying that classify the reviews into four categories in the examples. So this is one example, 2, 3, and 4. And this is the actual review for which we want a classification and there's a category. Okay. So the model should respond which particular category this particular review belongs to. And if I go on to run this, yeah, it basically says it belongs to food quality and restaurant ambience. And I can now iterate through all the reviews and provide. So this one becomes to food quality and restaurant ambience. This customer service, this is ambience, quality, and quality, right? You can see that this is a very streamlined way of executing that. Okay, now chaining multiple prompts. So there are two prompts here. One is a review prompt, which I am, which already we have developed here. If you see here, the review prompt. Where is the review prompt? Okay, review prompt is the first one. Yeah, that's a review prompt, which classifies into positive and negative, right? And then there's a category prompt, which basically classifies into, is a customer service or whatever particular category. And then there is a response to the customer also. So write an appropriate response to the customer by either appreciating the positive experience or addressing the specific concern of the customer with all the information. So if you see, there are three different prompts. One is the review, which is tells you is a positive or negative. Second one is a category, which tells you it's a customer service, ambience, and whatever. And then the final response to the customer. This is a final response chain. So you can see I will create kind of prompt chain here to find out the sentiment, the category, and the response to that. So I'm going to go into one chain. So this will actually involve three interactions with the LLM. And simply if I give a review now, the food tasted all right, but tables were not very clean, which is off-putting, right? This is the review. And if I basically give to the complete chain here now, it'll automatically do all the three tasks for you, right? And you see that it generates a response saying that we are sorry to hear that you are satisfied with the food quality during visit or whatever, right? Let's take one, two. Yeah. So thank you for the positive feedback. So it depends on the kind of review. It's not only find out the sentiments and categories, also generates a response for you, right? Based on different kinds of, let's say, yeah. Just have to hear about the negative experience customer. So of course, you can go through this example in detail to kind of get familiar with the coding part of it. But just to show you the demo, the line chain which will helps you to kind of streamline the development, right, of generative AI applications. So here we have used few shot prompting and prompt training, both of these concepts. Hmm. Any questions on this one? So go through this example. I will actually have a session somewhere in the middle of the week where you want a little more of a detailed code walkthrough. I will show you again. Okay, let's come back to where we have left off. There are also quite a few sites are there where you can actually get a lot of these prompt examples for your, for example, even OpenAI and Anthropic, they themselves even have a lot of these libraries, prompt libraries are there. Even Google also has. I find this particular document is very interesting and you can actually use that. For example, Google Gemini prompting guide. You can actually go, it's a very comprehensive guide, 68. At least the developers must go through it. So they have prompts, examples for different kinds of tasks, customer service, frontline management, human resources, marketing, project management, right? So different kinds of prompts they have, examples that you can look at it. Similarly, uh, even Anthropic and OpenAI also has examples of prompts. This will give you some direction in which, right, the prompts can be developed. So let's say you want to, so here's the prompt examples on the OpenAI itself. So explain a code, right? So this is the, of course, this is a very simple system instruction and the user message. Sometimes the simple instructions, but very clear instruction does wonder actually. Wonderful work. Review classifier. So it will be presented for the user review and you can choose from one of this, right? In fact, I have used the same example in my OpenAI example. Meeting note summarizer, right? The very simple instruction given here and the actual meeting notes. That does wonderful work here. Sometimes you don't have to have a very elaborate, simple, clear instructions itself is enough to do the work. Okay. So if you look at, when you're writing a prompt, just to reiterate the concepts, you can take help of LangChain Hub, where a lot of pre-built prompts are there for different kinds of tasks. And there are examples from all the major providers also there. You can explore that. But ultimately, you can also take help of the prompt generator, right, provided by Claude to generate a much more elaborate prompt. And you can also use Canvas to kind of collaborate developing this content. This is actually very useful when you're doing content generation or productivity, right? This is very helpful. Okay. So what I'll do is, so 9:30 now, maybe you can take a small break and come back and look at after that something called RAG systems. There's another important application or use case people use a lot called RAG system. We'll look at that. Okay. So shall we take a break? Quick break. 9:45 will join. Okay, welcome back. We'll get started now. We will look at few more tools and frameworks. One of the important application or use cases that are quite widely leveraged um, or used in industry is called RAG. Okay. RAG stands for retrieval augmented generation. This is called retrieval augmented generation. A second. So RAG technique is, of course, it has a multiple different objectives. One of the objective is uh, your LLMs have some limitations because the LLMs typically are trained on mostly public data set. And has no access to your private data sets or private documents, right? And even in the public data sets also, the LLMs are typically has a time cutoff because probably most of the models do not have access to the content that is generated yesterday, right? So if you look at even the models, for example, if I go to OpenAI models, there's a OpenAI models. And if I look at some of the models, you can see there's something called knowledge cutoff. The model, there's a context window. Context window is what is the size of the input that we can provide. So context window is the size of the prompt or the size of the input that we can provide. And then this is the output token, the size of the response that it can generate. There's always a limit to that. Then there is something called knowledge cutoff. That means this is actually trained on data that's available on internet or whatever the data set they used until October 2023, which is actually quite old. If you see, it's quite old. So none of the 2024 data is actually used for training these models. So that is one of the reasons why, if you look at nowadays, the models have a feature. If I go to ChatGPT, it has something called search the web. So this is actually, kind of a tool. It's kind of actually, also RAG system, but in a different sense, to get access to the latest data. But this is again for the public data. What if you have a private data? Right? You will have in organizations, you have a lot of private documents, organization documents, right? So if you want this knowledge to be also kind of integrated with your LLM system, so one of the techniques is basically called your RAG system, retrieval augmented generation. Now, one of the challenges, now imagine if you have, imagine you are an investment company, right? Financial investment company, and you have this financial reports of our organizations, right? And there are hundreds and hundreds of them, thousands of them. And you want to ask a question to an LLM, right? Saying that, okay, for manufacturing industry, and which companies, okay, has invested more than 4% in R&D. Now, let's say these are document in the last quarter, let's say. So now in these documents, because this knowledge is not available to LLM, now all the documents that belongs to the manufacturing industry also need to be sent along with the question as the context to the LLM. Okay, saying that, okay, here are the documents which has the reports, and here's the question. Now, can you answer this? The LLM. So it can do it, but then the context would be too large if I send all these documents as a part of the context, because I'm asking for a very specific information which might be available at a specific location or a specific section of the documents. Right? So rather than sending the whole document, and not all documents, only that belongs to the manufacturing sector, then let's say for this company C1, where the R&D spending is highlighted, R&D spending is highlighted. Not necessarily it has to be a, it can be any question, right? But nowadays, now there's something called, I'll come to that question. So let's discuss this one first. So let's say you send all this specific aspect, a specific section of the document to the model, right? Then how do you know which particular section of the document contains the information that required by the question that is sent or the prompt that is sent, right? So then the documents has to be indexed appropriately somewhere so that I can retrieve those specific components and add to the context. Okay, so that is part of the retrieval in RAG. In RAG, the retrieval part is how do I retrieve all the necessary section of the document and send to the LLM. Of course, over a period of time, the context size is also increasing. For example, if you look at Google, it supports 1 million tokens as a context size, unlike ChatGPT, which is typically 128,000 tokens only. But there are some models which has a larger context. But in spite of that, in a lot of cases where you cannot just dump everything, and it also add to the cost, because the larger prompt that you send, right, the prompt sizes, your charges will be based on the tokens, number of tokens in the context. Following me? So that's why RAG becomes an important solution. What is so Abhilash is asking, what is the best way to keep internal documents to be used by RAG? Okay, I'll come to that part now. So one of the approach is actually you send all these documents, right? So you take, for example, you can take each document. Let me first explain that in a process, and then I'll come to this. So what I do is you take the documents, just talk about one single document now, then we'll actually increase that. So take one document, and then what you do is you chunk the document. And now there are many different chunking strategies are there. So this is, of course, a big topic of discussion. So for the timing, you can simply say, if it's a very structured document, very follows a particular template, you can say section 1, section 2, section 3, section 4. It's not very structured. The random document, you can simply say, okay, first 1,000 characters, second 1,000 characters, 1,000 to 2,000 characters, 2,000 to 3,000 characters, right? You can also do some kind of chunking based on the character size, right? Paragraphs or sections. So there are different ways of chunking, semantic chunking. For example, you can look at the document and see, okay, the next chunk discusses a different subject compared to the first chunk. So different chunking strategies are there. Yeah, we'll come to that. So Abhilash has a question. I'll come to that part. Then what you do is you take each of this chunk, okay? Yeah. And then what you do is you embed them, right? You do embedding and you generate those embeddings. So you pass to the embedding model and generate those numerical representations, the embeddings, and store them into vector store. So this is basically called the indexing of documents in a vector store. Okay, so vector indexing. And then you take this particular chunk, again run through an embed model, and generate the embedding and store in the vector store. Right? And so on and so forth. And then this, of course, very naive first level of strategy. And then what you do is, once you have a document, you pass through a embedding model. That's why embedding models are very important in building the solutions. So you have embedding models also part of the solution. And then put that into a vector store, right? And then what you do is, let's say somebody ask a question in the prompt, right? Then you take that query itself, the question itself. Again, the question itself gets converted into an embedding, a numerical representation through the same model. Typically, the model that you use here and the model that you use here has to be same. You can't use different models, the same embedding model, because every embedding model has a different representations, space representations, vector space representations. So your documents gets chunked, embedded and stored in database, vector store. Then you ask a question. Then what you do is, once you generate the embedding of the query, now you see which of the embeddings of the chunks, right, are the nearest match to this query. Okay, so this is, you calculate that using something called cosine similarity. This is quite widely used. So you basically do a cosine similarity and find out which chunk is the nearest neighbor search. So all your vector databases or vector stores, that's one of the main feature. Okay? They use algorithms like approximate nearest neighbors, ANN algorithm, and find out which are the chunks the nearest match. So you can find out, let's say there are a few chunks, 4 or 5 different chunks are there. So let's say chunk 7, chunk 9, and chunk 10 are the nearest matches. You can, rather than picking just one chunk, you can pick like more than one chunk. Then what you do is, then once the chunk is retrieved, then we know which particular chunk, right? Then what you do is, then we create the prompt, the final prompt, saying that here is the question, and here is the chunk of the document, chunk 7, chunk 9, and chunk 10, as the context in the prompt, saying that this probably contains the answer, then can you answer the question now? So you can see that rather than giving the whole document, you are only giving specific sections of the document and then send to the model, right? And send to the model. And then the model LLM now, because now LLM in the prompt, basically you say that you answer the question only based on the information available in the chunk. And you can actually give a system instruction like that. And then what it does, it basically responds the query, right? So now the query will be much grounded. We call it grounded. With the information that's available in the context, it does not hallucinate, does not give information. You can actually add that to the system prompt saying that you only answer based on the information available. The information, sometimes it's also possible that the way we have chunked, the way we are calculating similarity, there will be some miss will be there. Sometimes you might actually miss. Okay. Of course, the probability of missing is could be quite low. Maybe in 1,000 queries, 1 or 2 queries can be. And then you say that if information is not available in the context, do not answer. Okay. Then you can iterate and send some more chunks and so on and so forth, right? So that's the basic idea of RAG, is to kind of take all the documents, chunk them, embed them, store vector store. When people ask, user queries come, embed them, find the nearest chunks, add that to the context, passed as a context of memory, and then send to the model to respond back. So this is a pattern, a very overall high-level pattern that seems to be working wonderfully. And the initial paper actually comes from Anthropic in 2021, I think, one of the, or a little before that, I don't remember, which proposed this idea, and it actually seems to have worked wonders. So that way you can actually ingest a lot of these internal documents out there. But of course, it comes with a lot of hyperparameters. Yes. So it goes a lot of the hyperparameters. For example, I think one of the questions, I think Abhilasa is asking, how do you know the chunk size? All right. So chunk size is something like an hyperparameter. Okay. So you can, in the evaluation stage, you can actually experiment with different chunk sizes. In fact, chunk size is one hyperparameter. Embedding size is also one hyperparameter, right? Embedding model and embedding size, because embedding is also as a vector, which is, has the dimensions, right? How many documents to choose? The K could be hyperparameter. So these are different parameters that have to be experimented with, right? And there's also a component called re-ranking. I'll come to that. That we add as another component here to select which of the chunks might be has a higher relevancy, right? With respect to the user query that was sent, can also use. So this is the base architecture, but you can add a lot of complexity to that. And how do this actually create chunks is also, besides simply size of the chunk, there are also a lot of this, interesting ideas that have come up. So when you take a document, right? When you take a document and you chunk them, if you chunk them, do a hard chunking. For example, the chunk 1 and chunk 2 are mutually exclusive because we chunk by size. There might be some sentences that might be, the context might have missed here. So there's a concept of overlapping. So each chunk has to be overlapped with the other chunk. Some amount of data would be overlapped, Like if you say create 2000 character chunks, 2000, maybe 200 or something just be overlapped so that you don't miss the context here. Second one is once you create the chunk also, right, you add some additional information to that. For example, you can create some document. Overall, what is this document is about? You can add some summary to the chunk. You add some metadata to the chunk, or you can also, there's something called context summary. You can add to the chunks before embedding it. So rather than taking the simple chunk, you can add a lot of other information to make sure that the chunk does not lose the context. So losing the context is a big challenge problem, right? So yeah, so this is a nice paper which was published by Anthropic introducing contextual retrieval. I'll send this link. I think you should read this. This is a very interesting paper, by the way. So in this case, what they're doing is, so that I think you can read that paper. Right, when the chunks are sent to the embedding model, right, and store in this is a standard RAG, right? You send the embedding model to the vector array, and sometimes you also do a TF-IDF retrieval, TF-IDF indexing. By the way, TF-IDF indexing is also called BM25 indexing filtering. This is what Elasticsearch has been using for many years, and this also works wonder. This is a hybrid approach used along with the vector store TF-IDF indexing. So context contextual, this is actually very interesting, and this has a much better accuracy. Is once you create the chunk, of course, there are many papers, suggesting many different ideas. So you create a chunk, you take the chunk, and then run the prompt for every chunk to situate it within the document. So what you do is you send the chunk along with the document to an LLM, saying that this particular chunk contains what information in the overall context of the document, and ask it to generate that context, a simple summary or concise information about the chunk in respect to the document. Then you add the context and chunk and then embed it and store data. So this actually works really well, but it comes with a cost. Right? So if you see, the failure rates have reduced significantly for contextual embeddings. So of course, this is a little more specific implementation, best practices and all that. But this is actually a very recent paper published by Anthropic, who are typically considered the leaders of RAG, because the idea came from them only, most of them. And of course, there are many other ideas are there. So simply chunking and embedding, there are a lot of other additional information you can add. Like you can have a metadata. Some of the keywords in the chunk, you can keep it. So keyword filtering you can do. You can add context of the chunk in the whole document and then embed it. So that gives you typically a better result compared to the standard RAG architecture. Okay, so there is a question from yeah. So Abhilash says RAG will always go along with vectorization. Don't know what the question means, but I think RAG uses both vectorization and your TF-IDF indexing mechanism typically, a hybrid approach people use. If that answers your question.
I just want to understand, like, if I'm using RAG, it is mandatory for me to do a vectorization for it, or It could not be that I can directly go and search these documents. It will not be possible.
I mean, then it will be like typical your no, traditional TF-ID, sorry, inverted index search, right? So this is going to take a lot of time. So when you're searching, I mean, basically you're saying that text-based search, isn't it?
Yes, yes.
Yeah. So text-based search are extremely expensive, and also the text could be, lose out a lot of information because it looks for the exact word or exact phrase in the document. Sometimes the synonyms on polysemy, for example, you can search for a particular word and you will use a synonym and that word is not available, then text search can actually miss it, right? That's why we use semantic retrieval. And for semantic retrieval, actually embeddings are very important. Okay, so embedding is in a standard component in RAG. Okay, you can't overcome that, but you can add that, uh, you know, add that semantic retrieval with your typical TF-IDF. If you have know what TF-IDF is, term frequency and inverse document frequency, this is for keyword search that Elastic uses. So this is a hybrid approach. You can actually do both of them. Typically gives a better result. But embeddings is definitely an vectorization is definitely an important component in RAG that cannot be skipped.
Okay, thank you.
So there's a question from Atul. In example of a restaurant review, where you have manually labeled 100 examples, is RAG appropriate method to feed information to the model? Or this is fine tuning related to use case? Actually, you're right. It's RAG. But if you see RAG has three components. RAG has a retrieval. What we discussed so far is called retrieval. Yes, this retrieval part can be used for your few short examples for retrieving. Same thing. So if you look at your feedback review example, you have hundreds of examples are there, right? Each example is embedded and stored in vector store. When somebody sends a review, I'll say which are the nearest reviews and add to that example context and send it. That's correct. It's a very simpler. Yeah. But there's something like retrieval, augment, and generation. Right, all three components are there. Very similar concept. Okay. So there also we do k nearest neighbor. Okay, or approximate nearest neighbor. Algorithm to find out the nearest example so that my classification accuracy improves. Absolutely.
Uh, but one my question is that if the new review doesn't include in any of those 100 examples, then how would LLM react?
So of course, I mean, there's nothing called exact match, by the way. So there's always an approximate match. That's why you call approximate nearest neighbor. Okay. So it's possible that you can actually simply what you do is you can calculate cosine similarity. Right? It's possible that the cosine similarity is very low. Some of the reviews, the cosine similarity could be very high, like 0.6, 0.7, and 0.8. And some could be very low, 0.3 or 0.4. Right? So even if it's a low, what you can do is you can simply add those examples as a LLM. But because these examples are not pretty good, it's possible that LLM probably doesn't learn and then probably misclassify it. Right? Misclassify it. It's possible. See, remember all these systems are called stochastic systems, right? So it's possible that if you got a completely very different kind of review that we have not seen before, the LM may not be able to classify correctly. Then when you identify that, okay, next iteration you add to the example so that the same review, similar review can get classified again. So that's basically a feedback mechanism that you do. There's always a possibility that whatever examples that you have created, that's why these examples that you create, no, there's a mechanism there. the way you create these examples to be included as a context for training LLM, there is actually a technique called uncertainty sampling, right? Uncertainty sampling, or there's a you can note down, there's something called active learning technique. Okay, you simply do not randomly pick up examples and add to the example. Even the 100 examples that you want to create, manually classify and add to, so they can be added to the context. These examples itself, the way they're selected, they're using called an active learning and uncertainty sample, which ensure that these examples kind of representational of different distributions. So they actually represent quite a wider distribution. Okay. So most of the times the reviews will be very similar to that. But in spite of that, there's a possibility that, sometimes in rare cases, there could be a review which does not have a similar match. Then in the next iteration, you do that. Got it?
Okay. Yes, I know we have not covered the fine tuning yet, but my general question was, when you have a scenario where you have manually labeled data of classification and everything, is fine-tuning the model a better technique than RAG? When you have manually labeled data in a database of, let's say, we create your database of classification and everything. In those, for PDF documents and everything, I understand RAG is the where you create chunks and you do those things. But when you create a database of labeled data, is fine-tuning better than RAG is what I'm trying to understand.
Now depends. We'll come to that question a little later. In fact, I have there's a flow diagram there. I'll cover that. When to
Okay,
use
okay,
fine
sure,
tuning and
sure.
when to use RAG.
Sure, sure. Okay, okay, sure.
Okay. So vector stores. So there are quite a few vector stores are there, by the way. You might have used or probably seen them. Like Chroma is open source vector store, and some are of course Elastic and all that are Waviate or proprietary systems and all that. And there's also an in-memory vector store out there, which is FAISS. We use that for especially demos, not really real-world implementations. Okay. So now all vector stores can be used. I think this is out of context. Yeah. So of course, when you have a multiple different documents, you can also have a multi-tier approach indexing. So when you have a documents that belongs to, and they're not flattened, right? All documents that don't belong to one category. Especially you can think like the situation of investment banking, where you have a sectors like a manufacturing, finance, retail, and all that. And within each sector, also large cap, mid cap, small cap, right? All those different are there. Then you have to structure those documents and the chunks has to be created like that. So when you create a chunk, right, of a document, you can actually add some metadata saying that, okay, it belongs to this particular hierarchy, right? So it belongs to, let's say, technology and this company and this particular filing. Every company has multiple different filings are there. The chunk belongs to that particular meta. So you can actually add a lot of metadata to that. So when people ask questions, let's say I'm asking a specific question about the Apple company and about a specific financial information that's available only in a particular filing in a chunk, then, rather than searching through all the chunks, you can only search through the chunks that actually satisfy this metadata of industry, company, and filing itself. So the chunks when you create, you can actually create a hierarchy like this and adds a lot of metadata to, to kind of narrow down the search, which is very important because in the real world, when you chunk documents of thousands and millions of documents, you cannot simply search through everything. And your vector stores are typically nowadays are very well designed to kind of, it's in like a typical database indexing, right, where you have where clause. right? In where clause you have a predicates or filtering criterias, and based on that, narrow down, right? It's called data skipping technique. The same thing also used in the same RAG that you can use. And then there is also, so the first stage is of course indexing, where you take documents, index them and store in the knowledge base like vector store. Second one is querying. You get the query and the query gets embedded. And then third is basically re-ranking, retrieval and re-ranking. Re-ranking is once the document is retrieved. So once the chunks are retrieved from the vector store, right? So let's say when you send a query, it says, okay, these are the 10 chunks, right, which has a similarity. Now, you don't add all the chunks, or you don't add all the chunks in the same order, right? So you can actually run a model called a re-ranking model. So these models are specially trained for ranking documents based on the relevancy, right? So there's a question and there's a context to the question. Says, so this model basically say, given the question, is this context relevant or not? Right? It actually gives a score called relevancy score. Now, based on that, you can actually find out, okay, out of the 10 chunks, maybe the 5 chunks has the highest relevance accuracy, I will use them, or probably in that order of relevancy score. This is also an important mechanism for RAG. In fact, there are companies like a Cohere. Cohere is again another leading vendor of LLM models, like your Anthropic and OpenAI. In fact, there are three different. To look at, there are four. There are four leading proprietary vendors for LLMs. One is of course OpenAI. One is Anthropic, cloud models. One is Google, of course, Gemini models, and then the Cohere. The four different companies which are the leading vendors. So OpenAI has a GPT models. Anthropic has a cloud models. So Amazon has invested heavily on Anthropic, almost like $5 billion. Google's are all called Gemini models. And Cohere has something called a command model, right? So, so these are four different major providers, proprietary models, right? They are not open source. So the command models. So they actually have three kind of. One is basically your typical GPT-4 kind of model, right? Prompt response. They also have embedding model, but they also built something called a re-ranking model. So increase search accuracy, prioritizing the most contextually relevant information within your enterprise data. In fact, they are the best model for re-ranking in the world today. So there's a re-ranking leaderboard. So they are the best model, re-ranking model. So people use their model especially to, so given the sequence rank 1, rank 2, so given a response, they'll find out the best matches from the content and then they'll rank them. Okay, so re-ranking models are popular, but there are also a lot of open source models also there. Yeah, so there's a BGE model also, it's an open source model, re-ranker based. Is quite widely used. The open source models also there. So you have to do a lot of benchmarking for your system when you're building it. Okay, so RAG systems are not easy to build. I mean, the base prototype might work, but a lot of complexity are there, especially when you have to end-to-end build systems. Okay, let's look at that's RAG system. So let me show you one example of that. A simple example though. So I am using, I think, OpenAI. Let me see. So I have a simple application of RAG. This is, of course, I'm using on one document only for demonstration. Of course, I'm using OpenAI. Llama Index I'm using. So Llama Index is an imaging framework. So let's look at Llama Index. The Llama Index is probably the most widely used framework for for RAG systems. Of course, nowadays even Elastic, Vespa, a lot of these proprietary companies, they also support RAG. So simply can install Llama Index and use it. So I'm just give me a second. I'm just showing the documentation. Yeah. So they were building RAG systems. So they all support agentic framework, structured data extract. So this is also very similar to your LangChain, but little more optimized for RAG systems. So they have a indexing, querying, re-ranking, everything. And if you look at the component guide, right, you can see a lot of things they support. Models. So embedding model, LLM models. So they comes pre-integrated actually. So a lot of this, see, the embeddings models pre-integrated with them. LLMs also, like LangChain, they also come with paid LLM API, open source LLMs, everything they come. Right. They also come with integration with storing vector stores. A lot of these vector stores are already integrated. Yeah, evaluation is something that we'll look at next week. And yeah. So I'm going to use one Llama Index here. So for this, I'm going to use, this is the Infosys report, financial report for the quarter 2023. And if you ask any question, either you have to embed the whole document or you can find out which chunk is relevant for the question, right? It automatically finds those chunks and does it. So let me show it. You see that it's asking for grant access to the OpenAI key. Sometimes it asks. Once you grant it, I think it will not ask again. So I'm using Llama Index, the framework, and I'm using FAISS, which is an in-memory vector store by Meta, Facebook actually. This in-memory, you can use it actually, but not for large scale. You have to integrate with a persistent meta store. And I'm using OpenAI model, ChatGPT, and I'm using also OpenAI embedding model. The two different models I'm going to use. You see that there's an LLM which is used for your final generation, right? So this is the LLM language model. This is for to generate the final response, and there's an embedding model. The two different models you have to use, embedding model and LLM. And I'm using a chunking here strategy, which sentence chunk size 512, overlap is 20. Okay. And this is the document I have to upload. So in the folder, I have to upload the document, Infosys document. Yeah. So read that document, then index it. The vector store, index it. So it's going to use the indexing strategy, right? Which you, the embedding model and the chunking strategy and all that. So that's a dimension of the embedding, 1536. Okay, that's a dimension of the embedding. And I'm using K2 strategy to retrieve to top two chunks and answer that. For example, I say, what is the revenue growth for the quarter? Right. You see that the revenue growth for the quarter is 4.2%. Yeah, it might have picked up this particular chunk. You also see the chunk also if you want. Which are some of the key customer wins? So in this case, this might have picked multiple different chunks. So key customer wins, yeah, client wins. You might have picked up all these chunks here, right? And they summarized it. So these are the key customer wins for the. What are some of the key achievements for the quarter? So depending on, right, the context. Yeah. So you can now see, you can answer questions from the document based on that. Okay. There is also a tool. See, sometimes what happens is sending these chunks to the OpenAI might be prohibitive, right? For example, you can't send private documents to that, right? So there is actually a tool. I'm going a little bit of back and forth. Of course, I'll cover all content. There's a tool called, I'm just looking for the tool. Yeah, Koteman. This is an open source tool, which is like a RAG system that you can install on your system, on your so let me show this particular component. So Koteman, this is actually a open source RAG system. It comes with a UI that you can install on your own system using Docker. If you have Docker, you can actually install it. So you can have a full version or light version. I've actually used light version. It's good enough, but you can also use the full version if you want. And what you can do is you can configure this. Ultimately, this is just RAG system, but you have to configure with embedding model and open source. Sorry, the LLM model. So what you can do is you can use some local LLMs. So next topic I'll talk about is local model deployment. So a lot of these LLMs, the smaller LLMs, are also quite capable now. In fact, 2025 is going to be the year of two things. One is small language models and agentic applications. The small language models are becoming quite powerful now. And you can actually deploy the models locally. And one of the tools to do that is yeah, that's what I'm answering the question now. So there is a tool called Olama. You might have used, I don't know. Olama. So getting up running large language models locally, actually. So you can download, this is available for Mac, Linux, and Windows. You can download and install it on your system. And if you go to models, okay, you can see it has hundreds of models which it supports. Of course, these are depends on the size. For example, this is 70 billion parameter model. We can't run it locally. But there are some models which are smaller. For example, I use Llama 3.2. which is 8 billion parameter model. 3 billion parameter model. And there's also a 8 billion parameter model. I'm not sure. There must be somewhere. I'm not just seeing it here. Right. So it has embedding model, the llama models, the vision model, in fact, there are a lot of tools also there. So once you install the llama models, right, what you can do is, I'll quickly show you also. For example, here, it's a llama list. You can see I am using quite a few. So I have a llama 3.2. There's a small LLM. This is a vision model. Gamma, 2 billion parameter model. Q1 is also vision model. And this is embedding model. So I've downloaded. This is typical the size. So llama 3.2 is about 2 GB in size. So what you can do is, based on which model you want, let's say I want this particular model 3.2, right? So based on which parameter, let's say 1 billion parameter or 3 billion parameter model, I can copy this command. The command is also not very complex. Llama run, and simply the name of the model. Okay, llama 3.2 colon the size, or simply just copy this. And you can say llama run 3.2 latest. So if you run this, if the model is not available, it will download it. It'll take a while to download because 2 GB, maybe 5-10 minutes. But once it's downloaded, it will run the model. Now the model is running, right? So let's say what is the right? So it actually can answer those questions. The capital India is there. So this is almost like a prompt only, right? What's the capital of India? Whatever the question is. And this is the you can say llama list to list what existing models you have, and llama run to run that particular model and then interact with it, right? This is like a typical your prompt response pair. And llama also has a web UI. So llama also has a web UI they have built. And this particular web UI, you can also download and configure it, right? You can do a pip install and solve it, or you can also do a Docker or non-Docker installation, depending on what you want to do. Then if you run that, let me show you. Yeah. So this, you can see that it's running on my local host 3040, if you see that. And this is now integrated with your llama systems, llama models. And if you download this, you can see all the llama models are shown here. Gamma 2B, 3.2, 3.7, all that. And this is a very similar feeling of your chart GPT also. So you can create a new chart, select a model, right? And then you can talk to that model. For example, if I ask, can you do a sentiment analysis? This is an instruction, this is the context, and this is a question. And I send to that. Let me see. Yeah, you see that? The llama. They're pretty good models actually. So based on the provided review, he has extracted keywords. So this is the review. And this review, it has the food quality is positive, hygiene is negative, customer support is neutral, right? It does a pretty good job because sentiment analysis is such a basic activity, right? And this is, of course, even smaller models are capable of doing it. So Atul has a question saying, what are the best frameworks creating an end user interface for chart? With this localhost, no data is going to internet. Everything is, yes, absolutely. Yeah. My model is running on my system, right? So I'm not using any OpenAI. So even if I know internet also, I can use it, right? Because my model is here only running on my local system and my US. So everything is local only. So even uploading document also, though this doesn't support, all right? Yeah, it's complete local. So you can play on the local models nowadays because local models becoming quite powerful nowadays. GPUs is what? I don't know. What is GPUs, Atul? GPUs. Acha, GPUs. Depending on what GPU you have, if you have a local system with NVIDIA GPU, it might work. Okay, but no, otherwise no. Yeah. So that's why if you see the inference is little slower because see the GPUs are typically required for training the model. For inference, you don't normally need GPUs. There are two different stages, right? One is training the model. A training model, of course, a lot of computation is required because do a back propagation, right? A loss calculation, all that. But then, you know, for inference, simply prediction of the next word, next token, GPUs are not required, but GPUs might be required if the load is very high and the inference time is very important, latency is important. But for normal work, you can actually do it on CPUs, for inference especially. There are models which are coming up for mobile devices also, like less than billion parameter model. In fact, Google has a couple of models for that. This capability of those models are a little limited because they don't have a large number of parameters. So there is a concept, of course, called distillation. It's a concept called distillation, which is an important concept, which is being leveraged, right? So knowledge distillation. So these models are actually trained on the output of the larger models. So they actually ask this question to the larger models, then use that prompt response pair to fine tune these models. So this is called knowledge distillation of larger model to smaller models. The larger model is typically called a teacher model and the student model. So they use a curated data set to do that. And these models are quite powerful nowadays. In fact, if you have a better system, like at least nowadays you have a laptops with 128 GB, 64 GB, you can run much better capable models. For example, one of the models that is actually making a lot of wave nowadays is QN model, which comes from Alibaba. It's a Chinese QN2, QN 2.5, right? They have up to 32 and 72 billion. So 72 billion parameter model is almost same as your GPT-4, performance. Not in all tasks, but quite a few. In fact, their QN model, which is 2.5 coder, which is 32 MB, 32 billion parameter, sorry, not MB, 32 billion parameter model, which would require at least about 40 GB of RAM to run. But that is not something that is very, no, new. Nowadays, a lot of people have systems, especially Mac with that much memory. So this particular model is pretty good in terms of code software development, almost as good as GPT-4. In some cases, it's actually better than GPT-4. That's what the benchmark says. Of course, how these benchmarks are, you can see that QN coder that will be instruct models, right? So there are different coding benchmarks are there, and most of the benchmarks is actually almost as good as GPT-4 or even better than that, right? Even better than Claude models. The benchmarks are there. In terms of SQL generation, code arena, there are some of the major benchmarks people run their models when they evaluate if the model is doing good or not. And except one, which is, I don't know, which we have to look in detail, what is that? So this is a pretty good model. So if you can just run it locally, or organizations also can actually deploy it locally to do that. Okay. So there are two things. One is Olama. Just to come to the conclusion, Olama. Olama is a platform, basically a tool that you can actually enable downloading and running models locally on your system. And then Olama also has a web UI, which actually gives you the same ChatGPT kind of interface, right? It also has, you can control these parameters, top P sampling, temperature, and all those things also can configure it, right? You can configure all those
Is
things
there
here.
any programmatic access for this one?
It also, yeah, fantastic question that you asked. Olama also has a programmatic interface. Thank you. So I'm going to show that next actually. So if you see here, yeah. So here is a simple, so they follow the OpenAI API standards. So here if you see, I'm using, Olama models, right? All that you have to use is use the same OpenAI API, but in the OpenAI API, you have to use the base URL as your local host 11434. That's where the Olama is running, by the way. Let me show that to you. So Olama is running, okay? So I can use that. I don't even, in fact, have to use any other code changes. I simply use the same thing only. They have their own, but I'm using instructors interface. So almost every model nowadays uses, even LangChain also. You see LangChain, Olama, sorry, yeah. See, LangChain also has an Olama interface. Simply give the model name and it will basically connect to that. Llama indexes, everybody is supporting now because there's a major provider now. And if you see that I'm actually doing a structured information extraction using the Olama model. An API key is simply Olama because I don't have a key here. It's simply open free. That's the default. Okay. And basically I call the same chart completion API. And the model is Llama 3.2 latest. That's what my model, right? Llama 3.2 latest. And let's say I'm giving this particular set of a message. I'm asking in that message, can you extract, these three elements, the name, team, and role. Right? You see that? I'm saying that this is the message, user message. And the response should be, of course, extract the user, which is nothing but your all that. And if I run this, now it's communicating with my Olama model, 3.2 model. And it's going to extract, yeah, the name is Dhoni and team is this and role is captain. Structured information, but you can do simple communications as well. It also has an API integration with that. And it has its own API, which is very similar to OpenAI. Or in a lot of these tools have their abstractions defined that you can use on the Olama models. Okay. So what you can do is, I'll just show you one more demo. Yeah, that's interesting question that Yaswant asking. When do we really need to pay paid service like OpenAI and all that? So of course, we have run one example and we've seen that it's working. But when you're doing a much more comprehensive application and you have evaluation set, you have to evaluate whether these models are, uh, having the same accuracy level or not. Okay. So small language models are typically very good at specific tasks, may not be very broad level of task if you want to do. Now people are using actually a hybrid model where there is single task, specialized task where they can use local models and you can also fine tune. We'll come to the question of fine tuning. And, you can also use the larger models, right? Yeah. So some of the tasks, maybe these models are not good, but some of the tasks could be good. So you have to basically evaluate and see if it's appropriate and then take a call on top of that. Okay. But if you want to do some basic classification, information extraction, all that, I think the smaller models are pretty good nowadays. Okay, I'll just show you one more demo of the tool and then we'll break today. It's already 11. We'll take up the next things next week. Let me see. Yeah, I want to use a tool called Koteman. I'm just seeing where the tool is. Yeah. The Koteman, this is again, I'm running on localhost 7860, if you see. And I have configured in the resources, the LLMs. I'm using Olama to default. And I'm using Olama 1134434 port number. And the model is a Llama 3.2. And for embeddings, I'm actually using a local model called Nomic Embed Text, which is, I showed you Nomic Embed Text. That's embedding model. That's a small, very small model, embedding model. I'm not using any re-ranking now. Simply LLM and embedding model. And retrieval settings. So retrieval mode is vector. Using vector, you can use vector or you can also use hybrid TF idea. And Olama for retrieval also. So I've configured all this and I have uploaded this file as an Infosys report. Okay, you can actually create a chart session, and then once you upload it, you can see once you upload it, automatically indexes it, right? You can also look at the files here. You can upload it here. It's currently it's already indexed and stored, vectorized and stored in the vector store. And once you do that, you can start asking questions here. And if you see, I have the beauty of this is, let's say, what was the earning of the Infosys for the last quarter, generate a response, and also shows you the page, right? From where it is retrieved here. Who are the key deals owned by Infosys last quarter? Give me the list in tabular format, deal name, customer name, and date, deal name in columns. We can see very beautifully it has a table with all the customer names, the deal size, and everything, right? And what kind of deal name, digital banking solution, cloud migration, IT modernization. And what are the top 3 key messages from the CEO? That's also shows it here. Okay, so let's say I'm asking just now, what are the key challenge faced by process? I don't know it's running or not. I'm just checking. I think it's something. I think I stopped it. It's not running, but it's working. Let me. Yeah. Okay. Let me. Can I take a little more time? 5-10 minutes.
Yeah, sure.
Yeah. I mean, it will work for quite a few documents. I mean, hundreds of documents. I mean, the full version definitely is going to work. If you have more memory and store and all that, then do it. Right. So let's. Yeah. Infosys Insights. Just to make sure it's running. Yeah. Yeah. You see that? So what are the cash flow in the last quarter according to the information provided in IFRS cash equal to 12,310 crores. Okay. And you can see this interesting is once you answers, it also gives you the chunks which actually it picked up. You can see that there are 2 or 3 chunks, at least 2 chunks. This is the first chunk and the second chunk. The relevance score is 0 because I'm not using relevance actually. I think I have switched up relevancy. I'm not using relevancy. That's why it's not doing that. Yeah, I think I have use relevant scoring. I'm not ticked. That's why I'm not using it. Otherwise, you can see the chunks it has picked up. You can also do the preview. It shows okay from where. So this is where the cash flow has come. See that it basically shows the evidence also. So this is where the cash flow has come. You can see that in the document. All this information is there. The text information is there. It's picked up very nicely. Right, I have installed the light version, but you can actually go and install it the high-end advanced version. It'll work. I have not benchmarked for hundreds of documents, but I have actually benchmarked for at least 10 documents, 10 to 12, 20 documents. It works nicely. But you can do that. Okay, there is another tool also there. There are quite a few open source tools are there nowadays, like a Varva. Waviate itself is actually built it. Varva. Waviate is very known company in the world of AI community edition. So they also have a very similar tool actually. You can install and try it out. So quite a few tools are not this ready-made open source tools. Use even Vespa also has. Vespa. Vespa engine. So this is also an RAG system that you can configure. This is actually very comprehensive. They have a cloud version that you can download it. So organize vectors, tensors, text structure, and serving time any scale. This is more of a very similar to Elastic Search, by the way. They are competitors of Elastic. So they may not have a generation, but they have a retrieval part of it very well defined. Information retrieval part. Okay. So there are quite a few, and these are the industry leading tools. Your LangChain, Llama framework, and there is this framework called Instructor, which is again, you can look at the GitHub stars. So they are the leading framework for structured information extraction, most probably for structured output. So how to define, so the simple example that I showed here, how to define a Pydantic class and give that as a model output, response model. What is that output? So extracting structured information is, this is the most important framework. Just 2 weeks back, Pydantic AI itself released a framework. It's a competitor of it now. Okay, so they themselves have released a framework now, which is actually used for. The Pydantic is very popular, by the way. Pydantic, it's a very popular library for schema enforcement in Python, because Python is loosely schema enforcement. So they themselves release something like Pydantic AI, which is it's getting quite popular now. And just to bring the session to the end, I will just show you one example, and then we'll stop it. Give me just 5-10 minutes. Then we can cover the rest of next week. Oh, where is my GitHub? Yeah. So structured information extraction using instructor. So this is a simple example of extracting information. So the two things we'll do next week is in the fine tuning. I think somebody is asking a question about fine tuning, agentic, and evaluation. Okay, and then we'll look at some AI safety aspects also. Yeah, this one. So this is a structured information extraction from a transcript of a team, which is they're having a discussion, and this is a transcript of that. And from the transcript, we actually extracted information about, they're discussing about what are the critical development, action items they have to do, prioritize them. And so we have several critical tasks we need to tackle for the upcoming release, and then you're talking about it to take it authentication improvement, the discussing all that, and then basically creates a very hierarchy of tasks, right? So this is the very nice graph that's created out of that, just to see that. So one is improve authentication system, front end revamp, back end revamp, integration authentication system with billing system, and so all that, right? So this can be done by library called instructor. So I'll just show you. You can run it actually if you want. So I have defined classes, how the information would be extracted. So tickets, these are basically tasks. And every task will have a name, description, priority, and the priority will be an enumerator with a high, medium, and low. And based on the discussion, they want to discuss it here. So medium priority task. So this should, and then subtasks, because every task will have a subtask also, right? So then what you do is you simply call GPT-4, right? And in the response, we simply okay, we have you have to extract tickets. That means basically the tasks. And it should be iterable, because there may not be one task, there'll be multiple tasks. So it'll be list of tasks. And then you provide the transcript. It actually can see that generates a beautiful schema of tasks, right? A list of JSON messages saying that, okay, the name, description, subtasks are this, and so on and so forth. And once you create in a JSON format, you can actually pass to GraphViz. GraphViz actually is a library for creating graphs. We normally use it for, if you remember, anybody working on ML, decision tree rendering, we can use GraphViz. And then we can use that to draw this nice graph here. Right? It's a very interesting and useful application. structured information extraction. People also do knowledge graph and all that. Okay. So instructor is a very, very important library for developing applications nowadays, which of course, an alternate to that is Pydantic AI now in just last 2 weeks. Let's come up. So that brings us to the end of today's session. Just to reiterate, we looked at primarily tools and frameworks and use cases. We looked at what are the possible use cases people might be developing using generative AI. And then we looked at some of the very, very important concepts like prompt generator, prompt canvas, prompt template, prompt chaining, prompt hub, and then frameworks like LangChain, Llama Index, Olama, right? And then tools, some of the tools like, instructor for structured information. So these are the leading tools in the industry today. Okay, there are of course alternatives are there. Everything has an alternative, but they're leading, and most of the things you can actually see from their GitHub stars, how people are actually leveraging, using them. Okay. A couple of things, try to install Olama and try to install Kotaman, and you can play around with it. If you have any difficulty, we'll actually have a session like last time on Wednesday evening. And if you have any specific problems, you can discuss in that. Okay, you can also run through some of the GitHub examples. And if you find any problem, again, we'll discuss during that class. Okay, so thank you. Unless you have a question, I will upload the video maybe in the afternoon once downloaded and send the slides to you. And see you next week. Abhilash is asking, is there a path where we can read the deck again? The slides, you mean the slides?
Yes, sir.
I've already sent, I'm sending the slides now in the email you must have received.
Okay. I just checked the video path. Okay, sir. I will just.
You would have received a slides link also.
Okay, sir. I'm just.
Yeah, I'll share all of them. Yeah. Yes, Arun, I'll share it. Thank you. See you next week.
Thank you, Prof.